Go. You're. Oh. All right. Good afternoon. So, we have been factoring essentially polynomials by hand. So we've been double bubbling. We've been looking for greatest common factor. Yesterday we did factor by, or the day before, factor by grouping. So we have been able to factor polynomials, and then we've been learning how to graph them just using the zeros and the end behavior. And so we talked about multiplicity yesterday. That was pretty nice. So this whole first half of this unit is figuring out all the different ways we can factor by hand. And long division is one of those methods that we need to know how to do, because sometimes we can't factor by hand without getting started first, and long division is the way to do that. So I'm actually going to show you two ways to do division, and you get to choose which one for the most part you want to do or get used to. So recall, we want to remember how to do long division. I'm talking 4th grade long division. And I want to do multiplying using the box method. So I'm going to start using multiplying using the box method really fast. So let's say we have like x plus 3, and we're going to multiply 2x squared minus 3x plus 7. All right. So we're going to multiply these two things together, and we want to figure out what it equals. So I know Nacho was a huge fan of the box method. But if you've lived with me for a while, maybe we haven't done it in a while. But anytime we have a binomial times a trinomial here, it's a great way to use the box. We have x and a positive 3 along one side, and I have to split that up. And then our trinomial goes on the top here, 2x squared minus 3x and a plus 7, and we can sort of, again, split that box up with all the signs. And then we just have to fill in the area. And the box method, I love the box method. It's super awesome. Keeps things organized. And so we are multiplying these two things together. So 2x squared times an x gives you 2x to the third. And then we would have, I'm going to fill down actually. So 2x squared times 3, 6x squared. I have negative 3x times another x. Negative 3x squared. Negative 3x times the 3. And then 7 times x, 7x, and 3 times 7, 21. And what we see when we do the box method is that we get the inside is the area. We just have to combine the things, right? So we get the 2x cubed. We have on the diagonal here, we have our like terms, 6x squared minus 3x squared, which is 3x squared, so a plus 3x squared. And then again on the diagonal, we have the negative 9x and the 7x, and that gives me a negative 2x. And then lastly, we get the plus 21. So all the like terms just combine on the diagonal, and that is kind of nice. And so all along our little diagonals here, 2x cubed plus 3x squared minus 2x, and the plus 21, everything just sort of combines on the diagonal there, and that is our result. So it turns out we can use the box method to actually divide instead of using long division. So if you really like the box method, you can do it in reverse. And what we have here to figure this out, this is the end result we just got. So our end result here is the x cubed plus the 4x squared minus 16x plus 8. That is the end result we got from combining. And what we're trying to do is we're dividing by the x minus 2, so that's one side. And we want to figure out what goes on top, and that's the question, what do we get on top to basically complete the box? So we're going to work through this. You can see how it works. Surely can, I'm sorry. Thank you. So I'm going to set up my box pretty much the same way, and on the left-hand side we have our x and our negative 2. We're trying to figure out what times x minus 2 gives us this 4-term expression. Exactly. We have to figure out what goes on the top. So what do we know? Right now, this is what we know. We know that this first box had to be an x cubed. So I know that that first thing had to be an x cubed. I also know that if I combine these two boxes, eventually I'm going to get the 4x squared. If I combine these two boxes on the diagonal, that should give me the negative 16x. And the very last box also has to be an 8. So I happen to know that one as well. So there's a couple of things that we can fill in, and I'm sorry, you can see that. And there's a couple of things that you can fill in, and then we can sort of work our way forwards and backwards to figure out what goes along the top. Exactly, because x squared times x is how we get the x cubed. Well, now I know what's on top. Can I figure out what's in here? Yeah. So x squared times negative 2 would be negative 2x squared. So now I know it's in that box. Now, how do I figure out what goes right here?
Well, you'd subtract that box from the total we have right now.
Right. So I know the total is supposed to be 4x squared. So what minus 2x squared is going to result in the 4x squared? Yeah, so 6x squared minus 2x squared gives me that 4, which is what we were looking for. All right, so now again, can I figure out what was on top then to get me the 6x squared? Yeah, 6x. Yeah, so 6x times x is how we got the 6x squared. Now that I know what's on top, can I figure out what's in the bottom box? Negative 12x, because 6x times negative 2 is negative 12x. Awesome. All right, and then again, working the diagonal here, what minus 12x is going to give me negative 16x? Negative 4x's, and a negative 12x gets me that negative 16x. Beautiful. And now that I have that box filled, I can, what goes on top? Negative 4. And double checking here, negative 4 times negative 2 gives me the positive 8. So it's kind of a nice built-in double check. All right, so to divide, here is our solution, x squared plus 6x minus 4. So if we were to, oh, sorry, thank you. If we were to multiply x squared plus 6x minus 4 times the x minus 2, it would give us our big little 4-term polynomial there. Okay, isn't that kind of interesting? Have you ever done division using the box method before?
No.
No, but you caught on pretty quick. All right, it was pretty good. Okay, it works. I haven't used it a ton. Actually, I only learned how to do it about a decade ago. So it's a pretty new thing in terms of teaching. But it does work. It works with remainders as well. But it's good to know. So you're going to have, Delta Math is going to walk you through a couple using the box method today. And so you can use it, but it's a cool kind of option, I think. Now, we also want to remember how to do long division. Long division is, everybody hates long division. Nobody likes long division, right? But it is a great, efficient tool. And honestly, if you learn the process, it's not that bad. So we're going to do 5,467 divided by 13, just to remember how to do long division. So 13 goes on the outside, and 5, 4, 6, 7 goes along the inside. I mean, I remember working with my son on long division. He hated long division. He just, because it has no meaning. It's completely meaningless. It's just a procedure. So us current math teachers hate this. Once upon a time, this was our only option. You just had to learn long division. We did literally long division for an entire year. Like, that's all we did every day in math. So the algorithm for long division is dads, mothers, sisters, brothers. Divide, multiply, subtract, bring down. And so we want to ask ourselves, hey, I have a 2-digit number here, and I'm going to look at the first 2 digits here. How many times would you say that 13 goes into 54? Around 3 times, 4 times? Yeah. So I might, you can maybe round that up to like 60, and maybe this is like 15. So yeah, I'd say 4 times. So we then multiply. So 4 times 13 is 52. And then, so that was the multiply part. And then we have to subtract. So we're doing 54 minus 52, which is 2. And then B is bring down. So we're going to bring down. And I'm going to say, I want to bring everything down so that we don't lose track of anything. Because that was the problem with long division, right? You don't get your columns lined up right. Something gets lost along the way. Okay, so, and then we just repeat the process and we're going to divide again. So we say, hey, 13 goes into 26 how many times? 2 times. And then we multiply. 2 times 13, 26. Then we subtract. 26 minus 26 is 0. And we bring down the 7. And then, hey, so we're not going to do decimal. Yeah, so this is our remainder. And so the way this works, because 13 doesn't go into 7. 7 is too small. And so this is our remainder. So we would say that 42 and 7/13 is how we write that. 42 and 7/13. It's remainder divided by divisor. That's what that is. So there is our lovely little quotient. So remainder 7 over whatever our divisor was. Now, we want to practice using long division because, again, it's messy. Well, it's a long process, but it's pretty fast when you get used to it. But I will say, ladies and gentlemen, please, please, please be very careful. So here we go. We want to do some long division here with x plus 4 goes on the outside, and we have 3x cubed plus 2x squared minus 37x plus 12. And the process is the same. Dads, mothers, sisters, brothers. Divide, multiply, subtract, bring down. Yeah. Would you ever have to use that? So you can use either one, box method or long division. I will say, you know, I haven't used box method as often, so I'm not as comfortable with it. Okay. But you can use either one. You can get a remainder sometimes. There is a little bit of a thing, like how does it work with the remainder? I'd have to go back and check that out. But here we go. Really, all we have to ask ourselves is say, hey, what times x is going to get me this leading term? We really don't have to divide. We can actually just go straight to multiply. 3x squared, sure. 3x squared times x. So here's the tricky part. When we multiply, we have to distribute. And that, I think, is the thing a lot of people forget. So we have to do 3x squared times x. That gets me my 3x cubed. And then we have 3x squared times 4, which is 12x squared. Now, I never change my signs. Some teachers get really, really messy. When we subtract, we have to subtract everything, and this is where all the mistakes happen all the time, okay? So I don't change my signs. I keep it straight out in front, and I just say it out loud really carefully. 3x cubed minus 3x cubed, 0. So I'm just going to cross that one out. Ladies and gentlemen, if it does not cross itself out, it is wrong. Right off the bat, that first term should always cancel out, okay? Now we go to the second term. 2x squared minus 12x squared. Negative 10x squared. So you can't just go 2 plus 12 and get 14x squared. So you have to subtract both of the things. So be very careful. And then we have to bring down. And again, I like to say bring down everything so that you lose track of nothing, okay? Now, once again, I'm going to say to myself, hey, x times what is going to give me my negative 10x squared? What should I put on top here? What times x gives me negative 10x? Yes. So negative 10x times x gives me negative 10x squared. Negative 10x times 4, negative 40x. And now subtract everything. And again, I use parentheses. I put the subtraction out in front, make it clear as day, really. Negative 10x squared minus a negative. What happens when we minus a negative? It becomes plus, so we have negative 10 and positive 10. That cancels out. Over here, negative 37x minus a negative 40x. Positive 3x's. negative 37 minus a negative 40. So that becomes plus 40. Negative 37 plus 40 gives you the 3x. And then bring down the 12. And now back up top, what times x gets us the 3x? A positive 3. So distributing 3 times x, we get 3x. And 3 times 4, we get 12. And there again, if we subtract everything, we would have 3 minus 3 is 0. And 12 minus 12, also 0. So we got remainder 0. How about that? It divided evenly. Okay, how are you with long division?
Done it for a long time.
Done it for a lot of years? Did you learn it in Algebra 1?
We probably did.
The end of the year for Algebra 2?
I
Never did it?
for a long time.
Okay, let's do it again. So we don't always get a remainder of 0, so we're going to keep practicing here. Let's do number 7. All right, number 7, x plus 1 divided into 3x cubed plus 7x squared plus 2x plus 3. All right, multiply, subtract, bring down. So we're saying what times x gives me my 3x cubed? Yeah.
You should be careful of that because it looks like an I.
Oh, yeah, funny. All right, there's a big dot there for multiply. Okay, so what times x gives me 3x cubed? 3x squared. All right, so now we distribute. What do we get when we distribute? 3x cubed plus 3x squared. Oh, that's what you're saying. Got it. I'm with you now. All right, so we subtract it all. Again, don't change signs. It just messes things up. You just think in your head carefully. 3x cubed minus 3x cubed goes away. 7x squared minus 3x squared. 4x squared. And bring everything down. So plus 2x and a plus 3. All right, back up to the top. What times x gives me 4x squared? Good, a positive 4x. Distribute. What do you get when you distribute? 4x squared plus 4x. Okay. And we subtract everything. Are you with me so far? Yeah? Okay.
If there's a remainder, do you write it the same way as last time?
Yeah, as the original problem, remainder over divisor. So that 4x squared minus 4x squared goes away, and 2x minus 4x, negative 2x. And then bring down the plus 3, and back up to the top. What times x gives me negative 2x? Negative 2, and we distribute. So we get negative 2x minus 2. You guys are fast. Good job. So 3 minus a negative 2 gives you 5. So there's our remainder. And so we get the answer to the division. The quotient is 3x squared plus 4x minus 2 plus remainder over divisor. Remainder over divisor. So 5 over x plus 1. So that's how you'd write it in Delta Math, yes. Okay? How are you feeling with long division now? Good? Okay? All right. Let's do number 11. Oh, do we need to do number 9? That has a 3 thing. Is that okay? Trinomial? You don't need to do that one? You're good with that? Okay. Let's go and look at number 11 then. So missing powers. When a power is missing, use a 0 to fill in the missing terms. So I always recommend just filling in the spaces because it just keeps everything nice and neat and organized. And so you can see here in the dividend, and this is the divisor, by the way, dividend, divisor, quotient is the answer. All right. In the dividend, we have a missing term, right? So I'm going to fill it in. We have 12x cubed plus 4x squared, and then I need plus 0x, and then plus the 4. So if you're missing a term, it's just a really good idea to fill it in. It just keeps everything nice and neat and organized. All right, so what times x gives me the 12x cubed? 12x squared. So that is 12x cubed plus 12x squared. And we're going to subtract it all. So that first one cancels out. 4x squared minus 12x squared is negative 8x squared. And then bring everything down. So plus 0x plus 4. All right, and back to the top. What times x gives me negative 8x squared? Negative 8x. All right. So distribute. What do we get when we distribute? Negative 8x squared. Negative 8x plus times 1 would be negative 8x. And we're going to subtract everything. Use parentheses. Keep it nice and neat. Negative 8x squared plus 8x squared is 0. And here we have 0 minus a negative 8x, which becomes positive 8x. Yep. And then bring down the 4. And then back up to the top. What times x gives you 8x? 8. Positive 8. And we distribute the 8. So 8 times x is 8x. And 8 times 1 is 8. Subtract it all. Goodbye. And then 4 minus 8 is negative 4.
Hey,
Hi.
I'm just seeing who's in this class, because we're about to talk about this.
Oh,
in
yeah.
algebra 2.
Well, listen in. Come on in. All right, remainder. So we have our quotient, 12x squared minus 8x plus 8. And then, so yeah. So I would just do a minus 4 over the x plus 1 is the...
Can you write it the other way?
So we could also write it, and it would be totally identical, but a little messier, to say plus a negative 4 over the x plus 1. It is not, it will not be wrong. It is not wrong. Okay? How are you doing? You doing okay? Good? Is this coming back to you at all? A little bit? Okay, okay, that's it then. Okay. Okay, do you have questions for me? No? Okay, lots of practice today on the Delta Math. And that was, yeah.